In this video, we're going to be proving trigonometric identities. And here's how this works. Proving or verifying, a lot of times they'll say, an identity means to show that both sides of the equation are the same. The way that we're going to show both sides are the same, or to prove an identity, we're going to simplify one side. Notice it says simplify. That's what we just finished doing. We're going to simplify one side of the equation until it's equal to the other side. It gives us a hint over here. It said work with a side that looks more complicated. So pretty much we're simply doing the exact same thing we did in the last video. We're going to take the complicated side and we're going to we're going to simplify it into this. So it pretty much is telling you the answer. We're wanting to make this side turn into the cosecant of theta to prove the identity. So let's try that. So we have cosecant times sine squared or cosine squared plus sine. So I'm going to turn first off cosecant into 1 over sine, and that's being multiplied by cosine squared, and we're going to add sine. So that's going to be cosine squared over sine plus sine over 1. Common denominator, we're going to multiply top and bottom over here by sine, so that's going to give me sine squared over sine, which I can now add the tops. That'll be cosine squared plus sine squared over sine. On top, that's Pythagorean identity. Sine squared plus cosine squared or vice versa will always equal 1. So I now have 1 over sine. I know that 1 over sine is equal to cosecant, which is what we were trying to turn it into. So check, those identities are true. The second one. Now, the more complicated side, really on this one, it could be either side. I'm going to work with my right side. I have secant, which I know is 1 over cosine minus cosine, which is cosine over 1. Common denominator here, let's see, I can multiply top and bottom over here by cosine. So I'm going to have cosine squared over cosine. So that would be 1 minus cosine squared over cosine. And then on top, I'm done because I know 1 minus cosine squared is actually sine squared by the Pythagorean identity. So I now have sine squared over cosine, which is what I was looking for. Number 3. It's obvious on this one that I am going to be working with the right side. I have sine squared times cosecant squared, which we know is 1 over sine squared, minus sine squared. But this one will be fairly simple. Sine squareds here cancel whenever you're multiplying, and it leaves me with 1 minus sine squared. And by Pythagorean identity, I know that 1 minus sine squared is cosine squared, which does check out with what I'm trying to simplify it into. The next one, tangent. Now this one looks pretty different. I'm going to distribute maybe my tangent to both of these. Tangent over 1, when I multiply it times the first one, the tangents will cancel and leaves me with just secant. When I multiply it by the second one, I have tangent times tangent, which will be tangent squared over secant. I'm going to find a common denominator here to where I can add these together. So I'm going to multiply top and bottom by secant. So I now have secant squared on top and just plain secant on bottom. So it would be secant squared minus tangent squared over secant. Now, secant squared minus tangent squared, that's probably going to connect to one of my Pythagorean identities. If you look at this one, if you were to move tangent squared over, secant squared minus tangent squared will equal 1. So we can replace that top, secant squared minus tangent squared, with simply 1. And I now have 1 over secant. And that's going to be a reciprocal identity. Anytime you have 1 over something, that's going to be a reciprocal identity. 1 over secant is equal to cosine. So therefore, that is what we were trying to get it to equal out to. It would be cosine. Number 5. Obviously, the right side is the more complicated side. I have 2 terms. They both have cosecant. So let's go ahead and factor out that cosecant squared. You're left with 1 minus sine squared. I know that 1 minus sine squared is a Pythagorean identity, and that I can replace it with cosine squared. Cosecant squared would be 1 over sine squared. So I now have 1 over sine squared times cosine squared, which would be cosine squared over sine squared. I know that cosine over sine by my quotient identities. Cosine over sine would be cotangent. So therefore, cosine squared over sine squared would be cotangent squared, which is what we were trying to get it to equal to. Now, number 6, notice we have some negative angles now. Anytime you have negative angles, now we've moved down, let's see, where are they at? Over here to our even and odd identities. And let's see what we can do with these negative angles. The tangent of a negative u. The tangent of a negative angle, we can put that negative out front. We can write that as the negative tangent of u. And you can put that u with it if you'd like to, but I don't. Times the sine of negative u. Okay, the sine of a negative angle, we can also move that negative out front. We're going to write that as the negative sine of u. Plus the cosine of a negative u. The cosine of a negative angle, we can actually just dump the negative. So we're just going to write that as the cosine of u. Or again, I don't usually put the angles. Now, if they were negative, obviously I would have had to put them, but once I make them positive angles, I just go ahead and get rid of them. Negative times a negative is going to be a positive, so those kind of cancel each other out. Tangent is going to be sine over cosine times sine plus cosine. So that gives me a sine squared over cosine plus cosine over 1. Let's get a common denominator by multiplying top and bottom of our second fraction by cosine. So therefore, I have a cosine on bottom and a cosine squared on top. And we probably already see where this is going. That'd be a sine squared plus cosine squared on top and a simple cosine on bottom. Sine squared plus cosine squared is Pythagorean. That's equal to 1. So I now have 1 over cosine, which is equal to secant, which is what we're trying to prove it's equal to. Number 7. 1 plus sine squared equals a really ugly thing on the right side. Now let's see if we can do anything with 1 plus cosecant squared. Let's see if that matches a Pythagorean identity. 1 plus cosecant squared is very similar to this. However, if I move that cosecant squared over, I would have 1 minus cosecant squared. So it really doesn't fit. Well, what about 1 plus cotangent squared on the bottom? 1 plus cotangent squared, yes, right here. 1 plus cotangent squared is equal to cosecant squared. So let's take the bottom and replace it. Let's see, I'm going to leave the top the same. Let's take the 1 plus cotangent squared on bottom and replace it with cosecant squared. Now let's split it. You have 1 over cosecant squared plus cosecant squared over cosecant squared. 1 over cosecant, that'd be sine squared, plus anything divided by itself would be 1, and that's what we're trying to get it to equal to. Number 8. Again, obviously the right side is the more complicated side. Let's go ahead and what we'll do is we'll turn all of these. You could try that trick to where we multiplied by the conjugate, but there's a problem. If you were to multiply this by the conjugate, you're going to end up with tan squared minus cotangent squared. And notice that none of these deal with cotan squares with tan squared. So instead, let's just go ahead and change everything to sines and cosines. Secant is going to be 1 over cosine. Cosecant is going to be plus 1 over sine. Over. Tangent is going to be sine over cosine. Plus cotangent is going to be cosine over sine. Now, lots of common denominators here. We're going to multiply top and bottom here by sine. So I'm going to do it out here. So times sine, and I'll have 2 on top. We'll multiply top and bottom here by cosine. So I'll have 2 on top. Same thing here. I'm going to multiply top and bottom here by sine. And multiply top and bottom here by cosine. So that turns my top of my fraction into, I've got a common denominator of sine times cosine. And the top is now sine plus cosine. On the bottom of my fraction, I have the exact same common denominator, sine times cosine. And the top is sine squared plus cosine squared. So this is going to clean up pretty nice here. The top is, well, let's go ahead and flip and multiply. But notice something, both of the bottoms are identical. So when you flip and multiply, those will actually cancel each other out completely. So on top of my fraction, I'm going to have sine plus cosine over this. Sine squared plus cosine squared, that's your Pythagorean identity, which is going to equal just 1. So if you notice what we're trying to get this to equal is sine plus cosine, well, that's what this is equal to, sine plus cosine, so we're done. Okay, number 9. You can really work with either side. Let's go ahead and we'll work with our bottom here. Well, actually, let's see. And when I said bottom, I meant by, you can multiply that by the conjugate, so that might be one way of working this. Let's see what we can do with the left side. Sometimes you might try one, it doesn't work that well, and then you try the other one. So let's see, we got cosecant, which I know is 1 over sine, plus inside here I have cotangent, which is cosine over sine. So I've got some common denominators already, so it might be best to work with this. So that's going to give me 1 plus cosine over sine, and that's being squared. Yeah, this might be good to work with. Now on top, the bottom's easy. You just square the sine. But on top, you have to square 1 plus cosine. That has to be FOILed. You're going to have to do 1 plus cosine times 1 plus cosine, which would be 1 times 1, which is 1. Cosine, or 1 times cosine, which is cosine, and then cosine plus 1 times 1 will also be cosine, so you're going to have 2 cosines. And then you have cosine times cosine, which will be cosine squared. So there's what you have on top, 1 plus 2 cosine plus cosine squared. And that kind of gets me stuck because I think, well, where do I go from there? And I get a little confused about it. So what I'm going to do, because again, you're going to make mistakes on these, and hopefully you see that from this problem. You're going to make mistakes on these, and sometimes you might have to go back and start over again. But I noticed something on bottom, that sine squared. Now this is probably going to be the hardest way of working this. That sine squared can be replaced with cosine stuff, and it's not really worked one quite like this before. But what I'm going to do, I'm going to replace that sine squared with 1 minus cosine squared. And the reason I did that is I know that 1 minus cosine squared can factor. And we're going to go back and work this an easier way because this one's going to be hard to see. Since you haven't been working these a whole lot, it'll be hard to work it like this. 1 minus cosine squared is difference of squares. It factors into 1 times itself, conjugates, and then cosine times itself. So we have a 1 plus cosine squared on top. We have a 1 plus cosine also on bottom now. So what I can now do is cancel this 1 plus cosine with one of the ones on top, and it leaves me with a 1 plus cosine on top and a 1 minus cosine on bottom, which is what you're trying to prove. Now that was probably hard, a little bit tough to see, so let's do something. Let's actually work with the right side now and show you. Go back to a trick that I actually showed you a little while ago. Now if you have a 1 minus cosine on bottom, you can actually turn that into this. Move the cosine squared over, you can turn it into 1 minus cosine squared by doing this. Multiply by the conjugate, which is 1 plus cosine. So let's multiply top and bottom by 1 plus cosine and see what happens. On top, you have 1 plus cosine times 1 plus cosine, which I'm going to leave for just a second as 1 plus cosine all squared. And then on bottom, you have conjugates, which would be 1 times 1, which would be 1 minus cosine times cosine would be cosine squared. And we know that that can be replaced with sine squared. So we now have 1 plus cosine all squared on top, and we have a sine squared on bottom. Now here's something you don't do a lot of. The whole top is being squared, the whole bottom is being squared. So we could actually say, well then, the top and the bottom is all being squared. So we're saying, most of the time we split it, but what we're doing, we're putting the fraction back together and saying that whole thing is being squared. Then we're going to say, okay, inside then, I can write as 1 over sine plus cosine over sine, which is going to be cosecant plus cotangent all squared, and that's what we were trying to turn it into. So some of these are a little tricky. You're going to have to manipulate them just a little bit. Okay, the number 10. Now this one we're going to use that same trick. Notice the 1 minus cosine here. We can multiply top and bottom of that by 1 plus cosine. And let's see what happens when we do that. Now, again, might work, it might not work. Let's see. So on top we have, and I'm going to leave it as sine times 1 plus cosine. I'm not going to distribute it quite yet, and you'll see why in just a second. On bottom you have conjugates. Multiply them, you get 1 minus cosine squared. Now, to save myself from rewriting this, that 1 minus cosine squared on bottom, we know that 1 minus cosine squared is sine squared. So over here I have plus 1 minus cosine over sine. Now I can find me a common denominator, which is going to be sine, by multiplying top and bottom by sine. There we go. So I have now, I am going to distribute it because it looks like some stuff will cancel. Sine times everything will be sine plus sine times cosine. Plus, here I'm going to distribute the sine, and that's going to give me sine minus sine times cosine, all over sine squared. The sine times cosine minus sine times cosine will cancel. And it leaves me with sine plus sine, which is 2 sines over sine squared. The sine on top cancels with 1 over on bottom and leaves me with 2 over sine. Now let's look at this. Why is it possible to rewrite this? This would be 2 over 1 times 1 over sine. Same thing. You don't have to split that if you learn this, but we know that 1 over sine is equal to cosecant, and that's what we were trying to get it to equal to, was 2 times cosecant. However, notice something, and this is what it reminds me of. Let me come over to the side and make a side note. If you have negative exponents, like 1 over x to the negative 3, remember how you can bring that to the top and it made it a positive exponent? Well, notice your reciprocal identities, what kind of happens. You had 2 over sine. When you brought the sine to the top, look what happened. Because we know that 1 over sine is equal to cosecant. It's kind of like when you bring a function, a trig function, across the fraction bar, it turns it into its reciprocal. And that's exactly what happens. If you have like 1 over cosine, as you bring cosine to the top, it would turn it into secant. It's a reciprocal. If you had tangent over 1, and you wanted to bring tangent to the bottom, it would become cotangent. It's reciprocal. So kind of think of it like that. If you have 2 over sine and you wanted to bring that sine up to the top, it would actually turn it into cosecant.